Hi, in this video we'll be exploring how to call stored procedures for reporting purposes. In the example, I'll create a custom table that passes parameters to the stored procedure and then returns a data set. The same principles could be used in Studio when creating a data model as well. Let's start with the example that I've pre-prepared here. So I have a product, in this case it's SAP Business 1, and in the table list I've added a custom table called My Account SP. So if we select that, you can see that I've got some mandatory filters that are pre-populated, and these mandatory filters pretty much mirror the parameters that need to be passed into the stored procedure. So here are our outputs, and if I preview the query and come to the information menu, I can view the SQL statement. This is the SQL statement that we'll be working on in this example. So we have a bit of logic at the start which creates a temporary table and then inserts the results of the stored procedure call into that table. And here we have the parameters. So this first parameter is the account code, and then we have a date range. Let's go now to Microsoft SQL Server Management Studio so we can explore how the SQL works for stored procedures. The same principles will apply if you're using Oracle or other databases, just the syntax will be slightly different. So for this SAP Business 1 database, I've created a stored procedure called My Custom SP, and it has three parameters. The first one is the account code, and then we have a date time parameter, which is the created date from and to. So this is going to be the range in which the creation dates fall into. And here is my SQL statement. So you can see I'm selecting just 3 columns from this particular table here, and then I've got the where clause, which is taking those parameters. If we test the stored procedure with some parameters, so no account and just a date range, you can see that it returns a result set. And if I set the account code, it'll just return that account for that date range. So from Sharperlight, what we need to do is call this stored procedure and pass in the parameters from the filter area into this section here. Now when you're selecting from a stored procedure, you'll need to insert the results into a temporary table, and the syntax will look something like this. You declare a variable of the type table and then define the structure. So just as we saw above, we've got an account code and account name, and the third column is the date the record was created on. So here we've defined the table structure, and then we're inserting into that table these columns from the stored procedure. And you can see I've just put in some arbitrary parameters just so I can see some results. Let's execute this snippet of SQL, and you'll see, sure enough, when we select from the temporary table, we're getting the results that we've passed into these parameters. Okay, let's start the creation of the custom table in the SAP Business 1 data model. Your data model may be something else, but the same principles apply. Now just before we start creating the custom table, by default all accounts do not have permissions to custom tables. So you'll need to make sure that you have the correct permissions to create the custom table. So in Site Setup, just select your target system. In my case, this is my account, and this is the system I would like to create the custom table in. And if you look at the properties over the side here, you can see allow custom tables. By default that'll be false. Just make sure that's set, otherwise you'll get a message saying that you can't create a custom table. Okay, so what I'd like to do now is start up Query Builder. I could be in Publisher or Excel, it doesn't really matter, as long as you can get to Query Builder, and from there you can start creating the custom tables. Okay, so this is the system I'd like to create it over, and if I just right click here, you can see there's custom tables, or I can go into the table selection list and there's custom tables there as well. So let's select that, and you can see I've worked on a few custom tables. What I'll do is create a new one. So just say OK to that, and the custom table will be on the connection to, in this case, SAP Business One. So it's now asking me if I've got some SQL. This SQL will be used to work out what columns exist in your custom table. So I'm going to say yes, and here's where I can put in my SQL. Let's go back to this example here. You can see if I execute that, it does bring out back some columns. So let's paste that in to this screen here where it's asking me for the details about the SQL. Down the bottom you have a unique code for the table and some sort of description. So I'm going to call this training SP accounts. So if I press OK now, it will try and execute this SQL statement and find the basic structure of the table. So press OK, and as long as there's no syntax errors, you should go into this screen here. So there's the basic summary of the table, and on the second tab you'll have table details. You can see that it's discovered the column names for that stored procedure that are returned by the stored procedure, and if we look at the table properties, you can see here it's just wrapped that SQL statement in brackets, so it's turned it into a virtual table, so it's going to try and select from that. This is not going to work without some additional changes to the syntax, but let's just try this out as it is now. Press OK, and because I didn't specify where I wanted the custom table, it's just put it in this folder here, and you can see there's a new one in the list. So I've just select from there. Now currently there's no mandatory filters, and there's our columns, and if we try and preview that, sure enough we get a SQL error. So it's got the columns up the top here, and it's basically trying to select from that, and because it's not really a real table, we're having trouble. What we want to do with this is basically push this temporary table and inserting from the executed stored procedure up to the top of the SQL statement. So move it up, that section up to the top, and then basically select out of the temporary table that's been created. So that's what we'll do next. I'm going to right click on the table, and you can see here we have custom tables, and we can go back and edit what we've done. I'm going to add more and more logic as we go. So there's our table that we're working on, and come across to the table details. So here's our table details. Now normally this would be the name of the table, which basically we want it just to be the temp. So we need to move this section up to the very top of the SQL statement that we're producing. So I'm just going to go up to make some room up the top here and have a look at the control tags button. There's various templates in here, and if I do a search on the keyword move, you see that it's given me some syntax for moving sections of the SQL statement right up to the top. So there's one move to top and there's move to bottom here. So I'm just going to double click on the move to top, and it's given me two keywords, and basically anything between these two keywords is going to go to the top of the SQL statement. So let's take that section out and put it between those two tags. and we could leave that as it is, but basically the table name that we're going to select from is going to be called temp now. So I'm just going to change that to temp, and we'll save that, and we'll see what the SQL statement looks like now when we execute it. So I'm going to press preview, just refresh that, and we are getting results now. If we come into the information button and preview the SQL that was generated, you can see that sure enough it moved that section to the top of the SQL statement, and then the engine's generated this SQL here, and it knows to select from the temp table, group by, etc. Right, so we're ready for the next stage now, where we set the account and the created date as filter parameters, and then we want to dynamically change these hard-coded values out for the ones that we filter on. As most stored procedures will only have a limited number of parameters, we'll need to lock down those filters. For example, the account code is just either blank or a single value, but the dates are a range. So we need to set those properties to make sure we lock it down that it can't do a range of accounts, it can only do one account, for example. Okay, let's go back and edit the custom table. So here's our hard-coded values. What we really want to do is take the account code filter value and put it in here. So the first step would be forcing these to be mandatory filters. So let's just go back up to the account code, and if we look at the filter properties, you can see here we've got mandatory values. So we'll set that to always for the account code, and then we also have filter restrictions. Because this stored procedure only takes a single value, let's look at the list of options we have here for filter restrictions. So there's single values only, and single no operators only once. So that would be a pretty good option for us to use. So we're only allowed to put one account in, no greater than, less than, and then for the date, the creation date, we'll do something similar. We'll set the mandatory values to always, and the filter restrictions, this time it'll be allow a range but no operators, and you're only allowed to filter on it once. Okay, here we have the default values for the filter, and for the date I'd like to default it to the last 10 years of data. So I'm going to put in the keyword date, and then I'll say minus 10y, which is going back 10 years, and the to value will be up to today's date, and just save some typing it in. And if I look at the account code, I'd like to default that to all in uppercase. This is a special keyword that means by default I just want all the accounts. Okay, so now we have these. Have a look at the code for each one of these. So there's our code for the account code, and then the create date. So these codes are what you reference the filter values by. Let's come into the SQL statement now for the table, and here are our hard-coded values. That's where we'd like to put in these filters. So the first one is the account code. I'm just going to make some space here. So if I have a look at the control tags list, there's a section called query details, and it's going to tell us about what items are filtered and what the values are and what comparison operators are in use. So come to filters, and up the top you can see I can reference the from and the to value of whatever code I'm after. So I'm going to select the from value, and it's put the syntax into the SQL statement. I'm just going to change the part that says code path to be ACC code, which is the field I'm after. And I'll just put the quotes around that. And then for the second line, I need the from and to for the create date. So I'll just copy that section there, and I'll change that. Instead of being account code, it'll be created date. Now this is not the description, it's actually the code. And the third parameter will be created date to. So that one there is the from, and that's the to value. Okay, so if we save this now, we should see when we preview the report some values coming into here that we've selected instead of those hard-coded values. So I'm going to press OK, close, and you can see the filter values aren't there at the moment. We just need to reselect that table and it'll force those mandatory filters up the top. So there's our last 10 years for the created date, and the account code is set to all. And if we output these values and we run the query, currently we're not getting anything at all, and I'll explain why. So here I've previewed the SQL statement that was generated, and you can see it's worked well. It's passed in the last 10 years as a range into the stored procedure, so that's good. But the account code's going in as the keyword all, so we're not getting any results. So really want to look at the all scenario and detect that and say, well, if the operator is all, which is we don't want to do anything at all. So before we adjust the logic to detect alls, let's just try out one of these accounts from the SQL statement that we executed before. So I'm going to try this account and just test this, and you can see it has worked. We've just got that one account, and if we check the SQL again, the stored procedure has been passed the correct value for the account code. So now when I edit the SQL, I'm going to put in some script around the parameters to try and detect if we've got blank accounts or we were doing all dates, just as we did before we edit the table. Okay. This message here is saying that I've got a local connection to the data model, so if I was to make modifications to the custom table, they're all local to me, and if you've got a service running, it won't pick up those changes because that's running outside. If I did the custom table modifications over a remote connection to the centralized server, everyone would see those changes immediately. So it's just warning me that currently I've got a local connection. Okay, so let's come back into here, and now we want to do a bit of an if statement around this to say if it's all, basically pass in a blank instead of the keyword all. If I just come down the bottom here, make some room, and go back to the control tags list, you can see there's a bit of flow control logic here where we can do if statements and switch statements as well. And under the query details filters, there's some templates that are already built up to detect if the filter operator is between, equal, greater than, less than, but we just want to know if it's all or not. So I'm just going to select that template called item operator detect all. And you can see it's given us a template. So there's our code path. So basically it'll be that one there. I'm going to move this above once I've got it finished. So if the operator is all, we want to do this, otherwise we want to do that. So I'm just going to move that up to the top here. And so if it's all, we want to pass in a blank to the stored procedure, otherwise we want to pass in what they've filtered, which is the account code value. And the same could happen for these created dates as well. For some reason they may select all dates. So we'll copy that section up there as well and just change the code to be, if the created date is all, what would we like to do? We'd probably just set an arbitrary date range, which would be from the past to the future. So I'm just going to put in 1900 0101 to 2020 1231. So I've put in a nice broad date range if the operator is all. So you can see that by using these if statements, you can actually change the behavior of the SQL statement. So you could have a filter in your table that's asking the user what mode would you like to do, or what stored procedure would you like to do, and you can change out any part of the SQL statement that gets executed, and the engine will resolve these at runtime, find out what they are, resolve them down to a SQL statement, and then that'll be executed. So let's see what happens now when we put in account all. It should substitute that in. If we put in a value, we'll get a different account code. We'll actually get the account code that we've entered in there. So I'll press OK now, and we'll test this. So at the moment I've got an account code value there, and if we preview that, yes, that's worked. And if we set that to all, like this, and we preview it, yes, it's given us all the accounts, and look at the SQL, and it's substituted in that blank. Now this detecting of whether it's all or not is actually quite necessary to do, because if we were to select on the lookup, we'd get SQL errors if we hadn't done that to sort of detect if the operator is all or not. Because if we look at the SQL statement itself, you can see it's tried to get a list of all the accounts. So it's executed a stored procedure and it's passed in blank and all dates. The next thing I'd like to look at is, let's put the account name in the lookup so that we're showing the code and the name. And the other thing that I'd like to do is, because this data model has multiple companies, if I was to change to this other company, which is in a separate database, I'd really like the SQL statement that's executed to change this prefix to the stored procedure. At the moment, it's still hard-coded to this Australian database. If we change to the Great Britain database, that's going to error if that's stored procedure. Well, it won't error, but it'll still be hard-coded to the wrong database. So we need to switch this bit of syntax on the front of the stored procedure out so it points to the right database. Depending on the example, you may not have to do this. Okay, so depending on your data model, it will usually have what we call a control tag that is already pre-prepared to determine what the prefix should be for tables. So if I select another arbitrary table from this particular data model, the system, in this case currencies, and if I preview the data and have a look at the SQL, you can see here we've got the SQL that was generated, and we just scroll down a bit, we can see the raw variables that before being resolved, and you can see this has prefixed this particular table with the company logic, and for SAP Business One it happens to be DBS, or the DB system. So if I was to prefix my stored procedure with that, it would put the correct company details on the front. So let's do that now. So I'm going to go back and edit the custom table again, come into the table properties and find my stored procedure. There it is there, and there's the prefix that I've hard-coded at the moment. If I change that for what's currently being used to prefix all the tables, that'll do the job. Of course, I need to make sure that that stored procedure also exists in the other database, otherwise I'm going to get an error saying that stored procedure doesn't exist. So SAP Business One happens to use this variable, curly bracket equals dbs, but if I was using another data model, for example, Great Plains, it may have something else. If you look at the control tags list, however, and go to query filters, usually up the top it'll list whatever that main filter, the very first filter is for selecting the database. So here it is here. So if you were after the company selection, just have a look at the very top there and it'll appear in the list. And you just got to make sure that you do the .dbo after it and make sure it's quote protected. Talking about quote protection, this account code, if for whatever reason it had quotes embedded in it, our store procedure would fail with a syntax error, because we've just said put quotes around whatever this filter value is. So you can imagine if it was a description, someone may have a quote embedded in there. So for that scenario, instead of doing quote around it all, what you do is you actually put the quotes inside this tag. If I have a look at the control tag list and look at filters, you can see that there are some examples. One's talking about quote protection, and you can see the example puts the quotes actually inside the filter tag brackets, and that way the engine knows that, okay, you better quote protect this sequence. So I'm just going to do the same syntax here. So take those quotes off the front and put it on the inside. So curly bracket question mark and then the quote, and so I'll put that on the inside of that quote like that. So now we've quote protected the parameter, and the next thing we're going to do is adjust that lookup on the account code. So select the account code, and if you come down at into the filter area, you can see the lookup is currently set to auto, and if I select the button we can get all the options, and I can change that to say do a field list, and when we show the lookup, show the account code and the account name, so those side by side. And we'll press OK and we're done. So let's go back, select our custom table, output all the values, and have a look at the account code lookup. You can see now, yes, we've got both in there, and I'll just select one account, go OK, there it is. And if we look preview the SQL, that variable that we had prefixing the stored procedure has been resolved correctly. And if we now change the database to another database and preview the results, sure enough, it's resolved the database selection correctly, and I had previously created that stored procedure in that database as well. So what we've seen here is how to create custom tables, but the same principles applied to Studio. We've seen that we can call a stored procedure and pass in parameters, and those parameters are obtained by referencing the filter values. And we've also seen how we can create if statements to detect certain conditions and change the way the SQL statement executes based on the filter parameters, for example. And we've also seen how we can switch out the database that the stored procedure resides under. In this example, I've shown how that one can call a stored procedure for reporting purposes. It's quite limiting doing reporting based on stored procedures, but there may be a library that you've pre-built, so you don't have much choice. You just need to work with that library. And you can see that Sharperlight does put filter where clauses around the set. So if there was a column, for example, the name of the account, and you wanted to filter on that, you would put that in the where clause, and even though the stored procedure doesn't support it as a parameter, it would still work. So let's just try that. I'm going to set it to all accounts, and if I bring up the name and said, for example, find anything that's like beginning with the letter C, and we preview, there's all the accounts that begin with the letter C. So the stored procedure didn't support that, but because it's been rolled up into a nice little data set, this where clause still takes effect. So that's an interesting benefit of wrapping the stored procedure up in SQL. Now, stored procedures sometimes are used to kick off tasks, and so an interesting concept would be that you call the stored procedure like we have here, but you're basically passing in filter values, which are the task code that you'd like to execute, or the particular journal that you'd like to clear down. So they could be used for kicking off tasks, and in that case you could just return an arbitrary value saying yes, the clear down was done, or the number of rows that were cleared down as the result of that. And that way, simply by defining a query through this interface, you could kick off tasks. There are a lot of ways to use stored procedures, but hopefully this has been enough to give you an idea how you can start the process.